good morning. Good morning, everybody. I do see that the number of participants is still climbing, but we have a very packed schedule today, so I think we should start. Chizama, are we ready?
Yes, we are, and I would like to confirm that all the speakers are in. Thank you, Prof.
Okay, great. Thank you. So let me start by saying a quick word of welcome to everybody who has joined this embassy lecture. I'm Stephanie Burton. I am simply here as the facilitator for this program, so I'm not going to be saying a great deal, but let me just make a few comments of introduction. This embassy lecture has been a plan which has been developed, was initially talked about in 2023 as a collaboration between the Academy of Science of South Africa, ASSAf, and the Czech Academy of Science. And the idea was that the lecture should serve as a strategic platform to strengthen dialogue and cooperation between South Africa and the Czech Republic. And the idea is that it will help to foster networks and collaborations and link science with foreign policy, but also through shared focus areas. So what we have today, what we're discussing today, relates very strongly to some of the important priorities both for ASSAf and for the Czech Academy of Science. And the program for today will be, I hope, enhancing the science diplomacy and collaboration that we share. The focus is on building resilience against climate impacts and at the same time developing collaboration. And you will be aware that South Africa hosted the G20 this year, and the theme that was for the whole G20 was around solidarity, equality, and sustainability. And the S20 Science 20 meeting, which ASSAf hosted, had as its theme climate change and well-being. So we have plenty of common ground on which to begin our discussions today. So we're going to begin by asking for some opening and welcome remarks from three of our colleagues who are here representing the Czech Academy and the Embassy and our Department of Science, Technology and Innovation. Thank you. We will have Dr. Janek Kresel, who is the Deputy Director of the Division of International Cooperation in the Czech Academy of Sciences, and then Mr. Dan du Toit, who is our Deputy Director General for International Cooperation and Resources in our Department of Science, Technology and Innovation, and then Mr. Petra Kapp, who is the Deputy Head of Mission from the Embassy of the Czech Republic in Pretoria. So let us ask each of those colleagues first, please, to give us your opening and welcome remarks. And Dr. Kresel first. Him. I think there might be a problem with that.
No, I was mute.
Now we hear you.
Sorry,
now we see you.
Typical mistake.
Please go ahead.
So good morning to all of you. So well, dear guests of the Embassy Lecture, on behalf of the Czech Academy of Sciences, I am pleased to welcome you to today's webinar. We are delighted to be co-hosting this event with our valued partners from South Africa, a country which we share a strong history of scientific collaboration. South Africa research institutions have long been important counterparts for many institutes within our academy. In the past, we enjoyed a fruitful and well-received cooperation through mobility projects with the National Research Foundation. Well, although this program unfortunately came to an end due to budgetary constraints on the NRF side, collaboration at the institutional level continues, and we are actively seeking new ways to support mobility and fostered the creation of new joint research teams. It is encouraging to see that efforts are now being made at the national level to formalize and strengthen research cooperation. We believe that initiatives like today's webinar play a vital role in supporting these efforts by bringing researchers together, sparking new ideas, and laying the groundwork for future cooperation. Today, we are talking about something that affects all of us, the way our climate changes within a single season. These short-term shifts in weather can have a big impact, especially in places where extreme weather, farming, and water supply are already under pressure. Understanding these changes help us make better forecasts, smarter decisions, and stronger communities. This is important for countries like South Africa and Czech Republic, where unpredictable weather is starting to affect key areas like agriculture and energy. By working together across borders, sharing data, doing joint research, and learning from each other, we can come up with better ways to prepare and to respond. That's what today's webinar is all about, building knowledge together and finding practical solutions to climate challenges that affect all of us. We hope this event will contribute to deeper engagement in research and innovation between the Czech Republic and South Africa, and we look forward to seeing connection and conversation that emerge from today's discussion. Well, thank you for joining us, and I wish you a productive, inspiring webinar.
Thank you very much.
Thank you.
Thank you. And now let me invite Mr. Don du Toit, representing our Department of Science, Technology and Innovation, to give his welcome remarks. Over to you, Don.
Thank you very much, Professor Burton, and good morning to everyone who's joining this event online, whether in Czechia or in South Africa. Indeed, it's a great pleasure for me, and certainly at the Department of Science, Technology and Innovation, we welcome this opportunity to, on behalf of the South African government, to really endorse the importance of this event. Today's event is aligned with several of the strategic objectives we attach great importance to in the Department of Science, Technology and Innovation for the role science should play in South Africa. As the two earlier speakers had already mentioned, of course, international cooperation is absolutely critical for science to progress. We like to say in our department that science knows no borders. And we know that throughout history, the enterprise of scientific discovery has always progressed when we share experience and expertise. So we welcome this event as a further boost to international cooperation in science. But of course, more than ever, it is important that science seek to respond to the key societal challenges we face. And there cannot be a more pressing, globally shared societal challenge than that of climate change. That is also the philosophy, the major policy philosophy of our department in our 10-year plan for science, technology and innovation, that we seek to organize our science system to respond to those key societal challenges, such as climate change, such as pandemic disease, such as food security. And then we therefore also see today's event as a very important mechanism for harnessing scientific advice and input into responding to these societal challenges. But of course, we also, and Professor Burton spoke about this, the role which science plays in reinforcing solidarity and reinforcing multilateralism. Those are values which are very important for South Africa, as evidenced also by our G20 presidency. So our expectations for this event, as was already alluded to by Dr. Kressel, South Africa and the Czech Republic are undertaking a number of initiatives to reinforce our bilateral collaboration, to build on the foundation which was there on the past, but also to create new, more ambitious instruments to support our collaboration. And we are very hopeful that, thanks also to the excellent support from the Czech Embassy in South Africa, that in the coming months we will be concluding a new bilateral agreement to support collaboration between our countries. And of course, South Africa and Czechia also has the opportunity to work together in the various programs of the European Union, such as Horizon Europe, the European Research Council, and others, where we have collaborated very fruitfully. I think also, Chairperson and colleagues, this event is very topical because, as you know, the leaders of the world are meeting as we speak in Belém in Brazil at the 30th meeting of the Convention of the Parties of the United Nations Framework Convention on Climate Change, and a message which is already resonating there again from Brazil, that for us as a collective, as a global humanity, to respond to the challenges of climate change, we need to increase our investment in scientific capability. And that again speaks to what I've spoken before, and that is that unique power of science to bring people together, to reinforce solidarity. And we believe at an age where there are multilateralism is under threat, the enterprise of science, the values of science, such as information integrity, research integrity, those are all values which need to be reinforced. And we do believe that events such as this can play a very important part in strengthening that. So I would just, in conclusion, first of all, like to thank the Academy of Science of South Africa for continuing for its excellent support in support of the South African National Science Agenda, and specifically our international cooperation. Throughout many years now, ASSAf has been a very progressive and positive actor for advancing science diplomacy. I already mentioned the Czech Embassy, and I see the Deputy Ambassador here, and through him, I would also specifically like to thank the Ambassador. We know that the Czech Embassy has significantly invested now over many years in strengthening knowledge partnerships between South Africa and Czechia, and we are really privileged to have them as a partner, and therefore very keen to reciprocate that excellent cooperation. And then lastly, me also thank all who have joined, participants in South Africa and Czechia. I think it should never be taken for granted that people invest their time in events such as this, but we know that if we work together, and specifically if we work together in science, that's when we can make a real contribution to making this world a better place. Thank you very much, Prof. Burton.
Thank you very much, Mr. du Toit, and I greatly appreciate your comments about collaboration. We now have some welcome remarks from Mr. Peter Kapp, who is the Deputy Head of Mission from the Embassy. So over to you.
Good morning, everybody. So I will just follow in line. Thank you very much.
Thank you very much, Peter. And if I may, I wonder if you would be prepared to share that presentation with the ASSAf colleagues, and we can then make it available. So the parts that were difficult to hear, we can at least perhaps put them onto our website with the recording of this meeting, so that people can hear more clearly your very important message. So thank you very much indeed. We will try to give everybody the words, the recording of that at least. So thank you to our three introductory speakers who have set a scene for us, which is related, all of it, to our interest, our shared interests and our shared priorities around collaboration and, of course, around the issues of climate change and sustainability and how we might be working together on all of these issues. So we now have two speakers who are experts in the field, if you like, and I am going to ask them each to give their presentations. Our first one is Dr. Katlego Mqongwane, who you will have seen from the introduction in our program, is the Senior Manager for Research and Development at the South African Weather Service. And she leads the development and implementation of research strategies that strengthen their organization's capability to generate and apply scientific knowledge. So we are going to hear, I think, a scientific presentation on environmental science and weather, and her work focuses on advancing the generation and application of climate information. So I think we're going to hear a very interesting presentation here. So Katlego, over to you for your presentation, and then after that I will introduce our second speaker. We all have some problems with, it must be the weather. I wonder if I could ask the ASSAf staff to contact Katlego and find out what her problem is, and perhaps we should go on to our second speaker while we try to sort that out. Okay, so I am going to do that. I'll take the chairman's liberty of asking if we can find out what the problem is with Katlego's system. But in the meantime, let me ask Dr. Aleš Urban, who is a research fellow with the Czech University of Life Sciences in Prague, to give his talk, and we will go back to Katlego afterwards. So Dr. Aleš Urban, a PhD in physical geography and geoecology, and is a research fellow at the Faculty of Environmental Science at the Czech University of Life Sciences, and he is going to address us also on the topic of climate and sustainability. So may I ask you to go ahead, please, Dr. Urban?
Yes, hello, good morning. I hope everyone can hear me and see me well.
We can.
I will share my screen. Yeah, so
good.
Yeah, basically my name is Aleš Urban. I'm affiliated with the Faculty of Environmental Sciences of the Czech University of Life Sciences, but I've been also working with the Institute of Atmospheric Physics of the Czech Academy of Sciences. And at least our understanding was that basically this initial lecture should be mainly about the impacts of climate on human health, which is which is a topic that me and my colleagues have been working on. So yeah, so basically I will introduce a few topics that we have been working on lately, and yeah, like there could be some space for potential collaboration. So yeah, like in general, we have beyond my colleagues, we have like let's say quite nice international collaboration in these topics of let's say climate and health, and especially me and my colleague Jan Kyselý, we are Czech representatives in the multi-country collaborative research network, which is an international collaborative network of epidemiological teams led by people from the London School of Hygiene and Tropical Medicine. And via this network, we basically are sharing epidemiological and weather data from the individual locations and are able to lead or contribute to global or continental-wide studies. And I will show you a few examples of studies that we have been leading in this collaboration. Then we have been also participating in several cost actions, so especially cost action Proclias, and now actually the follow-up cost action is Cross Cascade that just started recently. And as far as I understand, teams from South Africa can also participate in these cost actions. So maybe if someone is interested in this Cross Cascade or any other cost actions, they are definitely also welcome to join these cost actions. And I've been also participating or let's say leading the Czech team in One Horizon Europe project called Cross EU, and also collaborating with other colleagues in another Horizon Europe project. But yeah, maybe that's, and yeah, like as I said, or as was also introduced, I've been also collaborating, or I've been working with the Czech University of Life Sciences, like supervising students and lecturing. So that's basically now probably the main collaborative institution of let's say of our climatology team at the Institute of Atmospheric Sciences. And also, yeah, we have quite a long-term collaboration with the National Institute of Public Health. Via this institute, we are able basically to collect many health data sets and basically do the analysis. So the topics that we are working on are, let's say, there are three main directions. The first is focus on impacts of climate and weather variability on public health. And basically that's, as I said, due to the collaboration with the people from the National Public Health Institute, we have access to up-to-date data sets on daily mortality and hospitalizations, basically individual data. So we have already done a lot of research, but I just will give you a few examples. For example, yeah, like this is a study on the temporal changes in heat-related mortality in Prague, the capital of Czech Republic, and basically these curves compare like the exposure response relationship. That means like the basically, yeah, the relative risk of mortality over the temperature scale in previous 4 decades. And basically the main point is here to highlight this increasing heat-related mortality in Prague, or not only in Prague, but in general in Czech Republic, that we can observe, and that let's say has been quite significant, and especially due to the major heat wave events in the last decade, especially in 2015, 2018, there were like record-breaking heat waves and droughts in the Czech Republic that basically had a quite large impact on heat-related mortality. This is only in terms of Prague, but like this says like the number of heat attributable deaths in the individual years, and we can see like 300 deaths only in Prague, and like the number for whole country was about 1,000 excess deaths due to heat waves in that year. And like these plots show that based on some basically European data, we were able to analyze that actually Prague and not only in Prague, but like let's say these Eastern and Southeastern European cities have been one of the most, let's say, increasing in terms of the impact of heat waves on heat-related mortality or heat on mortality. And that might be related also, of course, like one factor is like, let's say, this increasing frequency and intensity of heat waves in this region, especially. I mean, of course, like the heat waves increase in the whole Europe, but especially in this region, we can, let's say, observe like faster, let's say, increase of the frequency and intensity. And also it's probably related to the demographic structure in these countries, where like like basically these, especially these, let's say, Central and Eastern European countries, like nowadays suffer with let's say from quite significant population aging. And yeah, so, and actually this is quite like kind of the link to the study that we have done recently, and where exactly the motivation was to analyze the impacts of climate change on temperature-related mortality in the Czech Republic, and include this factor of population aging, because that's really very important when we consider any impacts of climate change or whatever on human health now and in the future. And these plots show, basically compare the number of heat attributable deaths per 100,000 inhabitants due to heat and due to cold. And like the plots always compare the, let's say, constant population scenario, which means basically that we do not consider the population changing and we just consider, like, say, the increasing temperature scenarios, and then compare it with this changing population scenario that also includes to the analysis these basically demographic changes and the fact that basically, yeah, as I already said several times, like we expect quite a large population aging in the Czech Republic, and that means larger proportion of people in the age group, especially, yeah, basically above 75 years, and that means also a lot more people basically dying in this age group, of course, like especially the peak, we expect the peak around 2070s nowadays. And yeah, and you can see that basically this, including the population aging to the results, increases the impact of heat basically by almost 50% by the end of the century with the, let's say, with this more, let's say, skeptical scenario. That means RCP 8.5 and SSP 5, which is like, let's say, more pessimistic scenario in terms of climate change and also in terms of population aging. But even the, let's say, optimistic scenario still suggests that there is quite important impact of population aging. But what is maybe even more surprising or not so often presented is that like this population ages has impact also on cold-related mortality, because yeah, when I go back to this curve, we always like compare like the heat-related mortality is like the part of the curve above some minimum mortality temperature, and the cold-related is the whole part like basically below this let's say optimal temperature. Like in this case, I show only temperatures for summer, but otherwise, like in Czech Republic, we have way lower temperatures. So, but basically the point is that in general, the cold-related mortality is larger because we are not talking only about the extreme cold, but about the general cold. And yeah, and the point is that without the population aging, we would actually we could see like a decreasing impact of cold on mortality of like logically because of the, let's say, warming winters and general basically decreasing or warming, like, yeah, the cold extremes. But due to the population aging, the impact of the cold will be also actually increasing. So that basically means that to sum it up, that the population aging is really very important in considering these impacts of climate change on mortality or any other health impacts, and yeah, and it should be basically included in these studies. Like another topic that we focus on is the impact of extreme events and like say compound extreme events, and this is an example of one study that basically showed that like it focused on winter compound events, but like probably we could say the same about any other compound events, that but like this is an example that, for example, in this case like the extreme precipitation itself and extreme winds itself did not really significantly increase the impact on mortality, but when we focused on them as a compound events, they had like significant impact on mortality. So, and this is like one example of a study where we actually use these data from the MCC collaborative research networks. And in this case, we compared or evaluated the efficiency or the suitability of this ERA5 heat product, which is basically, I don't know how much you are familiar with these ERA5 datasets, but I will assume that people listening are familiar with the reanalysis ERA5, and there is also like this thermal comfort product, which basically calculates the UTCI, that means Universal Thermal Climate Index, based on the ERA5 data. And in this study, we used and compare like the stationed and these ERA5 based temperature and UTCI indices, and compared how basically the relative risk of cold or heat-related mortality differs for these different products. And it actually shows that, especially when we comparing like like the station data and the RFI data, that the results were very similar, which basically just supports the use of these reanalysis, and which is also quite important, especially in locations where, for example, the station data are not, let's say, so complete or in a good quality. So it's quite important, or let's say beneficial, to use these reanalysis in these kind of locations, especially. The second main topic that we focus on is the links between weather variability, infectious disease dynamics, and human mortality. And in terms of infectious disease dynamics, because we are quite cold country, so like the main infectious disease or the main infections that let's say bothers Czech Republic is are basically acute respiratory infections, and especially influenza epidemics that can increase the mortality in winter quite significantly. So we have actually recently, within one project, we have focused on this, like the links between the weather variability, this influenza epidemics and mortality. And in this specific study, we investigated like what is the additional effect of acute respiratory infections or influenza to the cold-related mortality. And this is what I was talking before, that like in Czech Republic, and not only in Czech Republic, but actually when we talk about heat or cold-related mortality, we usually talk about like the heat effect is above this like optimal temperature, like this small part, and cold-rated is basically this whole part below the optimum temperature with the lowest risk of mortality. And then what we can see here is the comparison between the models, like epidemiological models, when we included or did not include the effect of acute respiratory infections. And basically the main finding of this is that, yeah, like as we could expect, that basically influenza and acute respiratory infections affect the cold-related mortality, and basically approximately 12% of the cold-related deaths could be attributable to acute respiratory infections activity. Then in another study, we focus more on the links between the weather variability and the timing on influenza epidemics. And basically, I mean, that's also something what has been observed before, that air temperature and absolute humidity especially are, let's say, significantly linked with the timing of the onset of or outbreak of influenza epidemics. And then and what we actually found in this paper, that like for different types of epidemics, I mean, which means like the epidemics with different dominant virus, like the weather patterns may be slightly different. That, for example, for the, let's say, more severe epidemics that have more and higher impact on human mortality, and that are usually linked with the H3N2 virus, like so these epidemics are usually connected with let's say colder periods of in the winter season, while like the H1N1 epidemics, which is like the second quite let's say common dominant virus of epidemics, but this virus has, let's say, way weaker impacts on excess mortality. And like these epidemics usually occur in periods of average of above average temperatures. So basically, yeah, like we observed that there is this link between the, let's say, the dominant or the weather patterns and the dominant virus of the influenza epidemic and its impact on mortality. And then, like in another study, like actually one of my PhD students who has been recently in Barcelona, because we like, thanks to this PhD, we have been collaborating with the Institute of Global Health in Barcelona. And in her study, we let's say analyzed the impact of let's say interseasonal temperature-related mortality displacement. That means how, because yeah, like the motivation was to observe how basically this cold-related mortality, and also which is also affected by influenza epidemics, affects the heat-related mortality risk in the follow-up summer. And basically the main finding is that what we could expect, that basically in seasons or in years when the winter let's say cold-related mortality in winter is, let's say, higher than the impact of heat on mortality in the follow-up summer is lower. So basically there could be also this kind of mortality displacement or interseasonal mortality displacement, where part of the population that is at risk of, let's say, mortality in that season basically is affected by the seasonal or interseasonal timing of these, let's say, cold and heat extremes. And maybe the last topic that we have been focusing and recently is, let's say, exploring more the efficiency of adaptation strategies to mitigate adverse health outcomes, and especially in terms of main heat and health. And yeah, I've been involved to several programs or these projects, and like in this project we focus mainly on this heat and health. And in this study specifically, we used again like the data from the MCC collaborative network, and in these more than 100 locations we had like temperature and mortality data, and we also collected information about the heat prevention plans in these countries. And through these cost actions, and we were able basically to collect the information about like the time of the implementation of the heat prevention, or I mean, when I say heat prevention plan, I mean heat warning systems or heat action plans. So we used like this common term for all, and you can see here, or basically, yeah, the point was in the first part to sort of classify or evaluate these individual or these heat prevention plans in individual countries. And you can see that especially the southwestern European countries that experienced the major 2003 heat wave with a large impact on mortality, especially in Western Europe. So these countries have generally, let's say, more developed heat prevention plans, while like the northeastern and especially northern countries, like quite logically, because like the heat is not such a big concern there, have, let's say, less developed heat prevention plans. And then we also, yeah, like this is just another way to show the classification that especially UK, Portugal, France had like the let's say most complex heat prevention plans that also include like all the actions after the heat warning. That means like the focusing on the preparedness of heat of the health, I mean social care systems and particular care for vulnerable groups, and these kind of things that were not so much involved in these, let's say, simpler systems. And yeah, maybe I will jump.
Dr. Urban, are you nearly done? We've used up most of your time. If you could just wind up.
Okay. I'm sorry. I will just wrap up that like the main finding of this study was that we observe like 25% reduction of heat-related mortality associated with the implementation of heat prevention plans across Europe. And of course, like it was like different in different countries. But yeah, we actually, when we tested like the effect of these different level of heat prevention plans, we didn't see any significant effects. So there is still much more to investigate. But yeah, like this paper is recently under revision and hopefully in environmental research letters, and hopefully will be soon published. So yeah, so thank you. That's all from me. And yeah, sorry for if I was too long.
No, but thank you for the most amazing presentation of such a lot of data, such a lot of information that you have there. So thank you very much indeed. It was very enlightening to realize just how much you can use the data that you have. So thank you. Yeah. Colleagues, we do have Dr. Kadleho Nkwani back again. So I'm going to ask her if she can unmute and put on her camera and then give us her presentation. Dr. Kadleho, are you there?
Yes, good morning, colleagues. Can you hear me?
Good morning. Yes, we can.
Can you hear me?
We can hear you.
Oh, come on. Can you? Okay. No, I was starting to faint now. I'm actually connecting on my phone. I'm not sure what's wrong with my network. I'm not gonna touch much in terms of this. I think all of us are quite appraised in terms of the increase in global temperatures. These are multi-decadal increases, which result mainly from either natural forces, as we have seen when you're looking at the oceanic cycles. You look also in terms of atmospheric circulation. That especially when we look at the anthropogenic forcing, the increase in the greenhouse gases, which we are noting that is actually in a rise. We saw, a decline during COVID time in terms of the ppms. We have noted we actually have a background station at Cape Point where we measure, the increase in the various greenhouse components, and we actually noted quite a sharp decrease in terms of that. However, we are now on a increasing trajectory, and that compounded also with the increase in temperatures. We are noting also a combined impact in terms of other greenhouse elements like methane that actually have an extreme impact on human health. So when we note from the slide projected, the increase that we are actually noting from a global scale, when we zoom in terms of the South African or even rather regional analysis, you will note that there's actually almost a double increase in terms of what we are noting from the global side. That increase, as you've seen from the highlighted areas, we are seeing a sharp increase, from the western side of the country as well as you go to the north. And research has actually linked this to various systems such as your ENSO. If you can maybe move ahead to the next slide, please. So this is just some of the evidence of that actually back up what we're actually seeing even from the observation side, that there is an increase. And in terms of your monthly changes, as noted on the right hand side of the slide, there is those seasonal changes that are actually noted. You may move ahead, Dr. So this is just some additional evidence that are from the locally based, I'll say, publications. And on your left-hand side is research that is based on station data, whereby you can note a sharp increase in terms of the number of heat days that are noted, as well as a sharp increase in terms of the warm night. If you look in the long-term average cycle and maybe using a diurnal graph, you will know that as soon as you have a climate shift, if there is that increase in terms of the number of days is set. And if you look at the top panel, we actually note the number of extreme or maximum records that are changing on a day in South Africa. We actually have some of the highest records in terms of the changes in the maximum temperatures that are noted on the ground, and you will see even the monthly or the monthly changes that are there. And you will note that in our summer season and way through February, there is a high increase in terms of exposure, temperature, and when you combine that with other parameters, you will actually note that there is a sharp around the wet globe. and that lead us to then the combined impact of the different parameters, whereby when you take in your temperature as well as your humidity, and together with other climatic parameters, you will have a further exposure in terms of the heat. Doc, you may proceed kindly. All right. Okay, so this is just what I wanted to really highlight in terms of these. You will note that earlier we showed some changes in terms of the warming from the side of the Western Cape as well as up in the north. And what you are noting on this slide is actually the number of maximum record, and you will see that from the northern province side, where we have actually experienced a number of deaths, in particular from the elderly, as well as the outside workers. In this case, it was farm workers who were highly exposed to the extremes, and they were quite impacted. And I think 11 or so died as a result of exposure to heat. So I just wanted to just show that, to say in the western side of the country, certainly there is high exposure, and that is compounded also by various drought impacts. Colleagues, what I'm noting on this slide, and is quite key when you are looking within the science, the climate anomalies, which I've actually touched on earlier, whereby we are actually looking at those long-term, changes. But then within that framing, there is also changes in terms of your warm days, your cold days, as said, but also from the wet and the dry extremes. And as a result, we are actually seeing the increase also in terms of the number of extreme events or rather disasters that comes in the form of flooding, that comes in the form of drought. And sometimes we actually see a combined effect happening almost at the same time in the country, whereby you find that one region is actually, having, drought with very extended exposure, as well as UV exposures. And then you find that on the other side, there's an increase in their extremes. And as a result, if you can look at the world records, and you can move to the next slide, Dr. Tamaza. There's actually that sharp increase in terms of the number, the scale, and the complexity of those disasters, and impacting over 350 if you're looking at a global scale. We think that the disasters, if they will be quantified in terms of number, we can note over 11,000 disasters and reported disasters, because even how we actually capturing this information, it depends whether it will be, for example, recorded in MDA as an example, where there is also a classification in terms of that. But what I want to draw your attention now, it is that over sevenfold of those is actually hydrometric extreme, and 91% of those are experienced right here in Africa, where it has been noted from the current research that we have limited exposure in terms of the systems, early warning systems that are designed to forewarn and provide, the first responders and community levels with early warning systems. They are still not sufficient to help us mitigate the impact. Drawing closer to the aspect of heat, there is then that combined effect in South Africa. We have seen that when we have high temperatures, we will also have high increases in terms of your fire incidences. One in particular, it is the Knysna fire of 2017, whereby there is a high record in terms of the social impact as well as infrastructure damage. and the loss of life. And not only that, if you look into the agricultural side, Dr. Tomasa, you may move, please. If you look at the agricultural side, where there is a high impact in terms of agriculture, we have seen that heat also does perpetuate some of the drought impacts that we are noting. Dr. Thomas, I'm not sure, is it on my side? The slides are not moving. We may move. We may move. You may move. I think I did highlight this, and I also touched on their impacts, whereby we are seeing a combination in terms of heat, extreme heat or high temperatures, as well as the impact on the various systems that we depend on. You may move, Doc. So maybe trying to zoom in around the heat research. The National Adaptation document, which is currently under review, there are about 11, I'll say, heat or rather health impacts that have been noted as a priority in South Africa. And out of those, there is, of course, heat. There has been, and that is a personal reflection, I'll say a slow intake in terms of dedicated resources around the heat and early warning systems. A lot has been done around the flooding systems, as you've seen, even the joint committees that have been formulated and are actually managed at ministerial level. However, with the heat, which is quite silent, and because there are issues around having to document, as done, I think in Europe, in India, whereby they're able to actually quantify the number of deaths as attributed to heat. Therefore, there is the uptake in terms of our decision makers. It's quite slow. And if you look into the realm of heat, for us to be able to do high resolution at 300 meters modeling impact to capture your heat island, we require, infrastructure, which is part of the adaptive capacity elements that are required, in order for communities to adapt, in order for us to respond to the various heat impact in this case. And because we don't have, in terms of the ICT infrastructure, supercomputers for us to be able to crunch the numbers, to also intake or ingest, rather, insert observation, it becomes a challenge. So there is a need. There is good work that is done, from the SMRC side. There is good work that is done from the departmental side. But we are seeing an increase in terms of the impact, in particular on the most vulnerable. You look at your elders, you look at the children below the age of 5, you look at the people that are actually isolated, people that are living in corrugated in settlements. And in South Africa, that is one of the other areas where we are actually requiring some targeted interventions around heat waves and heat extremes in particular. So what I'm trying to show here, it is just, that full view in terms of the impact and how we really need to have, the right infrastructure so that we can be able to respond. Doc, you may move quickly to the next slide as I try to wrap up.
Yeah, please.
Yes. So what you're seeing here, it is just other products and services that are being produced. If you look at the lower part of the slide, we're actually showing heat vulnerability products and services that combine even the various geographical element, as well as human elements, whereby we are able to actually assess the vulnerability. And we have done a study there, if you can see at the district level, where we have actually do a projection around the 3 epochs, and you'll see that within those district municipality, there's actually an increase in terms of the heat exposure. And here we've actually targeted both the elderly and the young. Just wrapping up, and just only maybe you can just go through. It is just to show, you can just go through as I try and wrap up. From the weather service side, we do have, you know, a full suite of product and services around the heat. And if you can note in the previous slide, there's advisories, there's warnings. However, there is that need for us to have those combined product and services, and it requires that collective effort. And we are really appreciate that through this forum we are able to, you know, collaborate, you know, with Czech Republic as much as with other countries, so that we can be able to support, you know, resource capacity from the human element side, you know, to infrastructure side, whereby we strengthen even our model accuracy that will require then that joint effort. I will pause here and take any questions. Back to you, Chair. Thank you. My apologies for being long. Thank you.
Thank you. I think we won't take questions now. Thank you very much. I can see that you also have a huge amount of information, but we are actually running a bit late now. So we'll have questions and answers right at the end. We need to move on now to a panel discussion, which is going to be moderated by Dr. Thandi Kapwata, who is a scientist from the South African Medical Research Council. We have on the panel Dr. Andrzej Lokta, who is from the Institute of Atmospheric Physics in the Czech Academy of Science. We have Professor Willem Landman, who is a professor in meteorology at the University of Pretoria, and also our two guest speakers on the panel. So let me hand over to Dr. Kapwata to chair the panel discussion. Over to you.
Thank you so much, Prof. Burton. I hope you can hear me well.
We can.
Thank you. So this is just the part of the panel discussion between our 4 speakers. To start with, we will have a presentation by Professor Willem Landman from the University of Pretoria, and that will be followed by a presentation by Dr. Andrzej Lokta from the Institute of Atmospheric Physics of the Czech Academy of Sciences. Professor Landman, if we can start with you, please.
Good morning, everybody. Can you see my presentation?
Yes, we can. Thank you.
Okay. Yeah, so I'm just going to be talking about a few things that we do here at the university regarding forecasting. And so this timescale I'm also going to be focusing on is the seasonal timescale, which is the year-to-year variation of weather and climate. So it's not specifically talking about multi-decadal climate changes. It's about seasonal to interannual variability, most often associated with ENSO events. And speaking of which, this is a time series of rainfall as measured at my house. And so this is, although it's just for a single rain gauge or a single point, this is very much representative of what happens over the summer rainfall region of Southern Africa, south of about 15 degrees south. What you see here is that for the most part, when we have really wet seasons, we often have La Nina events, which is an event that is associated with cooling of the sea surface temperatures east of the dateline over the equatorial Pacific Ocean. And the opposite of that, La Nina, is when the sea surface temperatures over that region warms up. It's most often associated with drought conditions. And in particular, as you can see from this slide here, is that when we have El Nino seasons, it's most likely associated with extreme dry conditions. So then obviously it would be very helpful if we can predict these events, El Nino, La Nina events. And so here we show just some verification statistics of the forecast system that we have developed at the University of Pretoria that shows the sea surface temperature forecasts over this key area called the Niño 3.4 area, which is an area most well represented by ENSO El Niño Southern Oscillation events, and also an area that's strongly associated with our summer rainfall totals over the larger part of Southern Africa. So on the top left, you can see some verification statistics regarding making forecasts for 3-month seasons with lead times from 0 to 5 months ahead. And what it shows here is the typical so-called autumn barrier that's associated with low forecast skill when you try to make forecast of ENSO events too early in the year. But once we get beyond this, which is normally by the late winter, early spring season here in Southern Africa, we are starting to make absolutely wonderful forecasts of El Nino and La Nina events with several months ahead. Our system goes up to about 6 months ahead, but some systems that have been developed internationally are starting to make claims that they can predict this event 2 years in advance. I have my doubts about that, but anyway. So on the bottom left graph, although this is a rather complicated graph, what it shows is the association between hit rates and false alarm rates. So what you want is high hits and low false alarms. And for that to happen, these colored graphs, the red, blue and green ones, should go towards the top left-hand corner. And so the area beneath those curves is giving you some indication of discrimination. What that means is, are we able to discriminate El Nino events from other events? Are we able to discriminate La Nina events from other events? And are we able to discriminate events that are neither El Nino nor La Nina? And so what we see here is our great discrimination capability in predicting El Nino and La Nina events. So this slide shows we can actually predict these events several months ahead of time. So even without using any forecast models, if you know that an area such as my house is linked to ENSO, then we can actually make several months lead forecasts of whether or not there's going to be a wet or dry season at your farm or your house. The next slide is a very technical slide, and so I'm going to summarize it. What's supposed to be represented by this here is true verification results from the operational forecasts of rainfall that we issue at this university. We've been doing this since 2017, so we've got about 8 years of forecasts that we actually verify here. So it's not showing how a particular forecast model does. It's showing how good we are at the University of Pretoria making these seasonal forecasts. And this is specifically for the season of November, December, and January, which is the season in which we are finding ourselves in right now, predicted in August. So it's a few months lead time. And so what this shows, to summarize, is when we are predicting for wet seasons, we have good skill. When we are predicting for dry seasons, we have good skill. But when we are trying to predict for what happens in the middle, we don't have any skill. So this is something that we sometimes find difficult to comprehend. This is something that we actually struggled with in the beginning of this whole effort to make seasonal forecasts in the 1990s. We thought it would be easier to say to a farmer or to a user, listen, we don't really see any clear signal from the models. I think it's going to be a normal season. And so we have lots of evidence that shows that is kind of the worst forecast we can ever make. So although we have seen some warning signs that things are getting worse, the extremes are more likely to happen, it actually is, I'm trying to bring good news here, in that we are able to more able to capture the extreme seasons. We are not really good at predicting what happens in the middle, whether or not we're going to get a normal season. But in terms of extremes, you are actually doing quite an admirable job. Now I'm going to show just a few applied forecasts. This is so-called tailored forecast. We have a whole range of different ones. I'm just going to show a few here. And this is particular for the inflows into Lake Kariba. This is work we've now done more than 10 years ago now. And this was because of that big flooding event in 2010-11, where it rained so much over SADC. and the water that went into Kariba was just too much for them to handle. And they just phoned Gorabasa downstream and said, listen, we're just going to open our sluice gates, just deal with this. We don't have, we can't keep the water anymore. And so what we tried to do here is to ask the question, could we have predicted this catastrophe? And what you see on the left is true forecasts. It's not actually forecasts that we issued, but this is a situation where we have simulated the real operational forecast setting. And this shows that we have, with 5 months ahead of time, with high certainty associated with the blue bars of very high inflows going into Lake Kariba. The graph just to the right of that shows the categories. The red dot shows below normal flows. Anything lower than the red dot is below normal. Anything above the blue dot is above normal, and the big black dot is the actual observation. So this forecast is actually quite accurate. And so what you see on the right is our latest forecast, a forecast that was just issued last month, and showing forecasts in terms of probability of exceedance and in terms of inflows again. So what we see here is is two curves. The black curve shows the climatological curve. So that's calculated over a long period of time. And the green one shows the actual forecasts. So if this green curve is to the right of the black curve, it shows increased likelihood of high inflows. So now we already warning ahead of time that there's going to be lots of water going to Lake Kariba. Now, this is an interesting piece of work. And so what this shows is the modeling work that we've done for a particular farmer in terms of crop yields. And so we've developed a system in predicting crop yields, and what we've demonstrated here is our ability to actually make forecasts in also what we would regard as a true operational forecast setting. So for the most part, the forecasts, which are the purple, which is the purple time series, and blue, which is the observed time series, in terms of yield, a yield index is like, it's actually just a normalized yield total. Shows that the forecast model is actually quite good, except for this period towards the end of the 1990s and the beginning of the 2000s, where the forecasts were for really very favorable outcomes, above normal. If we talk about these three categories of above normal, near normal, and below normal, above normal forecasts, and yet the actual observation was for below normal. And so what we see here is a 2-category miss. And although this is a deterministic statement, forecasts are normally issued in terms of probabilities of the likelihood of each of these categories occurring. And so what we did then is we tied a very simplified economic model. It's not really a model, it's more like an equation or a formula that takes the following into consideration. The forecasts are very skillful.
Sorry, Prof. Landman, just a 2-minute warning, please.
Yeah, I'm almost done. Thank you. And so what this shows is if the farmer invests money in the forecasts, he can actually make a lot of profit. And so what we then see, because of the money that invests in the forecasts, if the forecasts go terribly wrong, those accumulated profits can be wiped out. But if he makes very informed decisions based on forecast verification, he can actually cater for seasons where forecasts are going really badly. So this is an example of where we actually worked closely with farmers, and not just issuing a forecast map and showing where it's going to be wet or dry, but actually going to a farmer and addressing the needs of that particular farmer. And that was my last slide. Thank you.
Thank you very much. We now hand over to Dr. Andre Lochter.
Hello, can you hear me well?
Yes, we can. Thank you.
Yes, I will share a couple of slides of me, but I will ask my previous speaker to unshare your presentation, please. Thank you. And I will share a mind thought. Can you see it in full mode now?
Not yet. We're still seeing yes, that's good. Thank you.
Yeah, okay. So I will try to be quick. I will talk briefly about the heat waves and our research on variability, their modeling, and related uncertainties. I am from the Czech Academy of Sciences, from the Institute of Atmospheric Physics. So, I think I can go through this very briefly. The first chapter or the first starting point will be the observed changes in heat wave. Then I will talk briefly about climate change scenarios of heat waves. And my third talking point will be about the related uncertainties in climate change projections. So to introduce, there is no universal definition of heat wave, but I suppose that many of us also experience at least one heat wave, so we can all imagine what the heat wave is. And my favorite piece of paper, mainly about 20 years ago, was already published. The Mehel and Tebaldi concluded that heat waves will become more intense, more frequent, and longer lasting in the second half of the 21st century. And we already seen it today, as you can see on the figure right. Across the whole world, new records are broken, new temperature records. So, and this situation is the same also in Europe. Here you can see that in the last about 2 decades, many extreme events occurred across Europe, and the trend is quite clear. Since the new millennia, since the year 2000s, we have, or the European citizens experience much more major heat waves that the previous generation experienced. This is just another viewpoint of this issue. In the map on the left-hand side, there you can see a most extreme heat wave, but also from the 1950 to 2001 period. When on the other hand, on the right-hand side, there is an updated map with more recent data. And you can see that more than 80% of European area experienced the most severe heat wave in the past 2 decades. This is not a surprise because we have more and more greenhouse gases in the atmosphere, and if you have more greenhouse gas in the atmosphere, there is more or higher global temperatures, and higher global temperatures have a better or higher potential to develop a stronger heat wave. But as you can see, the future changes depends mainly on the concentration on the greenhouse gases, and this is the one of the uncertainties in which I will be talking briefly. We know that heat waves will be more intense, longer lasting, and more severe in the future, but we are not able to give, let's say, precise projections of this event because, as you can see on the figure, the uncertainty is quite large because the models disagree on frequencies on future heat waves. They agree that the heat waves will be more stronger, more intense, but they are in disagreement how strong this increase will be. So I would like here to highlight the three main sources of uncertainties. The first source, I already talked about that. It's the concentration of greenhouse gases because more greenhouse gases mean a warmer atmosphere. The second one is natural variability of climate. It is sometimes forgotten in climate change research, but still, for example, the modes of climate variability or the ocean forcing and its changes still can modify the let's say the intensity and severity of heat waves and other phenomena, as we can see in the last previous presentation. But now I will talk mainly about the imperfection of climate models because this is the third main source of uncertainty in heat wave projections. In Europe, heat waves are basically linked to specific synoptic condition. We need a atmospheric blocking anticyclone sometimes over Northern Europe, as you can see on these figures. And in our previous research, we were interested if climate models can simulate this pattern well or not. And as you can see here, some models have realistic, let's say, synoptic patterns leading to heat wave, but many models, despite they simulate quite strong heat wave, they captured the synoptic conditions quite wrong. So it seems that the models compensate from, for example, different circulation pattern with some other sources. And these sources are land-atmosphere coupling. If I can put it very simply, some models are very dry. There is very low precipitation before heat wave. They have very dry surface, and the heat waves are created or enhanced just due to this very dry condition. In those models, they don't need the strong advection of warm air or very strong persistent anticyclone. They just need the dry surface, which is not which we are observing in Central Europe, and the models are quite inaccurate here. At least some of them. And the last thing, this is quite new research for us. We also checked how the models can simulate the vertical structure of heat waves, because heat waves are not located only near the ground, but they grow up nearly through the whole troposphere. And we were interested if climate models can reproduce this pattern. In short, some of them could, some of them not really, some of them couldn't. So to wrap up, I would like to highlight that the severity of heat wave is increasing in Europe as well as in many world regions, especially in the last 2 decades. And this trend is projected to continue due to the continuous rise of greenhouse gas emissions from the human society. And the last point is that the climate models can reproduce the increase of heat waves, but the future of this increase is quite uncertain because there are a lot of uncertainties and model imperfection. So thank you very much. And if you are interested, there is my email, so you can always contact me. Thank you.
Thank you very much, Dr. Lokta. At this point, I will bring in, excuse me, I will bring in all our 4 speakers so that we can have a discussion about the presentations and also get some questions from the attendees of the webinar. So while we collect the questions in the chat, if maybe I can just get us started with a few questions. See already some, the team is still collecting the questions. So I'll just start with a few questions and then we'll just go through the chat and look for questions from the attendees. My first question is to Dr. Urban. So you gave us a very interesting presentation around the health impacts of heat, especially with regards to increasing mortality. I was just wondering, in terms of translating science into action, how do you think your work could strengthen heat early warning systems in the Czech Republic?
Yeah, so hello again, and thank you for the question. And well, how to answer this? Yeah, I think like recently actually we have been like there is a like not only me but like many like researchers from climate and health or in general in Prague from different institutions. We have some sort of, let's say, living lab or something like that organized by the city of Prague. So actually, and like we have, for example, like last week actually we had one seminar where we all met and like basically presented the latest research. And also in previous years, we basically at least once per year we have this kind of meeting of the people from the different institutions focusing on this topic. And I mean, organized by the city, by the Department of Environmental Protection. And yeah, so I guess I can say that like especially, I mean, in last let's say 5 years, like the city is really trying to, let's say, uptake, let's say, the information or the results from the institutions and use them in preparing new strategies, new adaptation measures and so on. And now actually, at least as far as I know, they have been also collaborating on developing of the new heat warning systems. And I'm not really directly involved in this, but like I believe that like this whole, let's say, meetings or regular meetings of the institutions kind of help or motivate these people from the city to
Definitely.
to work on that, and and they have the contacts and they can discuss this with all
Take the actions forward. Yeah.
Mhm.
Thank you so much. And then to Dr. Katlego. You've given us a very comprehensive overview of the wide-ranging impacts of heat, not only on health, but on the environment as well. I was wondering if you could give us an indication of any interventions or any adaptation strategies that are being driven or supported by the Weather Service.
Dr. Tandy, can you come again?
I was saying you've given us a very comprehensive overview of the wide-ranging impacts of heat on not only health, but on the environment as well. And I was wondering if you could give us an indication of any interventions or any adaptation strategies that are being driven or supported by the Weather Service.
Look, Tandy, heat is quite a systematic and affect, all social systems. So from our side, when we are looking at the impacts on human side, it is the need to have an integrated solution or product and services that will actually combine exposure as well as vulnerability. So that is not just about, the meteorological intensity, but we're actually to reflect the actual potential impacts. And that is now when you're looking at exposure on human health. But over above, to put a step forward in terms of translating those product and services so that the communities are able to understand those solutions that are being put across. And also in the same breath to apply, across the time scale. I think you've noted from the various speakers, Dr. Landman, and also our colleagues from Czech Republic. Across those time scales, there is an importance for us to integrate the impact-based warning so that it's not just about, the meteorological intensities, but it's also about, what is it that the people need to do on the ground. So coming back to your question, I think the biggest intervention, it will be to collaborate and work very closely with disasters managers on the ground to assist in terms of moving the needle in terms of the various interventions that requires a collective effort. So that's what we are doing on the environmental side, is just to increase our efforts in terms of our measurements, in terms of our verification processes, the blending methodologies that we need to bring in so that we can have those scientifically credible product and services to service across the various sectors, not just from the human health, but then to touch on the environmental side, as you've well said, and also to look at also in terms of the economic solutions that are the I'll pause there in terms of my response, but then that is largely about that, the actors on the ground, the systems that needs to be in place, and then also the collective efforts across the chain from everyone, starting with individuals. And thank you, Dr. Tandy.
Thank you so much for that response. And then just one more for Prof. Willem. I was wondering what implications do the seasonal extremes that you were showing us have for regional climate change response strategies?
Okay, we are expecting everything to warm up. Some models are predicting drier conditions. So seasonal forecasting is, of course, it's an adaptation tool. And so what happens over the next couple of months is where the decisions are actually being made. In terms of health, you are very well aware of the fact that we've successfully developed a malaria forecast model. And those models are successful because of the strong impact of climate variability. So especially over the low-feld areas, when malaria is a big problem, that particular area has a very strong connection with ENSO. And so because of that, we can actually predict whether or not there's going to be a season of high counts or low counts of malaria problems. In terms of flows in the Limpopo Basin, for example, we can actually quite skillfully, months ahead of time, predict whether or not there's going to be an inundation of rain that will lead to flooding. So there's a lot of these kind of impacts that we can actually predict several months ahead of time. And as I've said in my talk, it's actually quite ironic that we are not so good at predicting what may happen in the middle, but very good at predicting what happens on the extremes. So there's great hope on seasonal timescales, and the shorter timescales, the so-called S2S, the sub-seasonal timescales, there we've not been as successful, I would say. There's been a lot of work going on between this university and the Weather Service in trying to create these sub-seasonal forecast models, and the success that we've had has mostly been associated with predicting of temperature extremes, not so much rainfall, and also restricted to the first 2 weeks. The third week from now, the forecasts are not particularly helpful. But for the next 2 weeks, these extreme temperature forecasts have been shown in the work that we've done together with these two institutions, that there's actually great hope in warning people ahead of time whether or not there's an extreme heat event coming.
Thank you very much. Really interesting. And then just this is to the entire panel, just from your perspectives, hearing talks from the Czech Republic and from South Africa, how do you think that bilateral science efforts can move forward, how we deal with the challenges of climate change in our respective countries?
Yeah, sorry to jump in here. This is one of the big differences between a European country like that and our country, or our region, is that the success of what we do here is very strongly linked with how we co-produce forecasts. And so the example I presented with of the inflow forecast in Lake Kariba, we went there, asked them for data, did the modeling. 3 years later, PhD student, 3 research papers, and then you said to them, okay, look at what we created for you. And they said, who asked you to do this? Our operations manual is more interested to know how much water flows over big falls. We don't want to know 5 months ahead of time when there's going to be a lot of water into our lake. We don't know how to handle that kind of information. So if we had sat around a table with them to discuss what it actually is that they want, I think this project could have been much more successful. And this is one of the sensitivities in this region. I would imagine it's quite different in Europe, is that there's a great need for the so-called end-to-end discussion between the forecast producers, the scientists, and the people actually going to end up using this stuff. We've been very successful. Sorry for going on too long. We've been very successful in doing this work with the malaria guys because we included them right from the beginning. And so this has been a successful endeavor, but the Kariba guys, it's actually been quite a disaster. Sorry.
Yeah. I think that's a good example, Prof. Landman, of the importance of roundtable discussions with all stakeholders, so that whatever you're implementing speaks to the needs of the various stakeholders. That's very important. Anybody else from the panel wishes to expand on that?
Dr. Tandy, just to jump in, and I'll keep it quite quick. I think we really need coordination, even among ourselves. And even before we can actually move outside and collaborate with our international partners. But within the country, there's a lot of silos working. So I think efforts around coordination across the different sectors with academia, with institutions like yourself from SMRC is required. But more importantly, I think we really need a whole, government approach in terms of how we are going to tackle this because of the multi-impacts across health, energy, event planning, disaster risks, and also risk management. So we need all the skills. What we've noted, around the model development in Africa, we really don't develop our own model. We rely on models from overseas. So there is a need for us as a country to put resources around model development so that we are able to really ensure that the models that are being employed really are able to work for us. And then lastly, I think sustainable funding mechanisms. I think we need that so that we can be able to put the necessary resources on the ground to capacitate, working very closely with the Department of Science and Technology. I think you have noted, in terms of our skilling, we are still a little bit at the back foot, so we need to strengthen also capacity building around that so that we can have sustainability in terms of human resources that will drive and develop these systems that we really depend on in this climate environment. I'll pause there. Thank you.
Thank you, Katlego. I mean, I also agree, definitely, we do need to invest more in terms of skills transfer and skills sharing so that we can, we can benefit more from these bilateral relationships. I also agree about the platforms locally as well for us to be able to share the vast amount of work that's been done, but again, in these silos that you so accurately refer to. We will go into the chat. Please, if any of the attendees have questions, please just raise your hand so you can pose your question to our panelists. In the meantime, we have a question from Suman, and she's asking Alez to explain how does he link weather variability, like temperature variability, to decreased mortality?
Sorry, disease mortality.
Disease, oh, sorry, disease mortality. Thank you, Suman.
Yeah, thank you for the question. And I've basically put a link to one paper to answer in the chat, but in general, yeah, we have been using these, let's say, epidemiological models. It's called quasi-Poisson regression models for time series regression. And now, and recently, mainly this methodology developed by Antonio Gasparini, like it's called distributed lag nonlinear models, which like has the advantage that it also considers the lagged effect of temperature or other weather variables on the health variables. So it doesn't basically correlate only the immediate effect, but at the same time in like one kind of cross basis function, it considers also the lagged effects. And yeah, there is a lot of let's say literature and like even codes like available online, free available, like papers by Antonio Gasparini and his team from the London School of Hygiene and Tropical Medicine. And also like nowadays, like via this MCC network, like there are many papers like using basically this methodology in different applications. And also at his personal website, if you go to the website to the like website of Antonio Gasparini, you will find like access to many examples of codes, for example, R codes using these models. So yeah, like to, I guess, basically it's yeah, like some statistical model that estimates the relative risk of mortality at different temperatures, and yeah, so it's some kind of estimation of probability of mortality or dying or having some case of some disease or like at some specific temperature compared to some reference temperature. And yeah, and so it's I guess, I don't know if I answered your question fully, but yeah.
Okay. Thank you so much,
Alex.
Alex.
I think I will look at the references you have talked about, Antonio Parinini, to get on this matter more. Thank you.
Thank you.
Thank you, Suman. We have a question from Constance Zungu. Constance, I wonder if you could unmute and pose your question to the panel. No. Okay. So Constance's question. Constance is from Newcastle. That's a town in the KwaZulu-Natal province, and she says we have a serious flood problem every year, especially in town. Just 2 days ago, many shops were badly affected, and she would like to be a part of any project that helps with this issue. So maybe this is for Dr. Katlego.
Yeah, and look, I think it's the same question that we hear every year, and we even ask ourselves every year, because flooding, in particular in KZN, is quite persistent. However, not so much is being done in terms of the interventions. I've noted that there are different chain of command in terms of what is we are able to do as a collective. There's an aspect of urban planning, and also the function that is done by the different municipalities that will actually put in place the various protocols that they need to follow in the event of flooding. However, it's quite complex, colleagues. You'll find that within those municipalities, people will put in their settlement, around the floodplains, and even after they've been moved, they will actually revert to those areas that are quite risky. So as I said, from our side, from the Med Savers, I think what we are able to do in terms of the information out there, I think we are doing as much as possible. But then there are those chain of command from the information to the disaster managers, and to that lady who is at that particular floodplain. So we currently actually looking at some research, working with SANZA to try and also integrate, satellite information. And we hope that our quest will actually be heated, from the government side in terms of urban planning, because the disasters in terms of the flooding will remain because of those, I'll say, or what is it, foundational, physical. And I think Dr. Landman can place it very well. I think our climate is characterized, so flooding is still going to be there. So therefore, we need to do test beds in terms of protocols of how to evacuate, how the information needs to trickle down, so that we can be able to protect the lives. But otherwise, there is a whole lot of projects that are being done by different entities, and the main thing is to come at the ground and work with colleagues like yourself. Back to you, Dr. Tandi.
Thank you, Katlego.
Thank you.
Maybe you can share some of those initiatives with ASSAf to share on their websites for other people who might have the same questions as Constance did. Thank you so much for your time. At this point, this brings us to the end of our panel discussion. We have one more question. I will hand over to Professor Burton right now to maybe do the closing. Thank you, Prof.
Thank you. Actually, before I close, I wanted to ask if any of the panel can tell us about any programs that they have or that they're aware of, which enable the public to understand at the level of non-experts, whether there are any programs that they're aware of whereby the public can actually understand the importance of the modeling and the significance of the forecasting, and where it comes from, where that data comes from. Willem, I see you just turned your camera on.
Yeah, so what we tried a couple of years back is trying to understand the notion of citizen science. And so what we've asked farmers and people who live in cities who have actually collected decades of rainfall data to supply us with their data. So what we did then is we took their data and developed seasonal forecasting systems for them. We've been particularly successful over places like northern Namibia. And in fact, the farmer lady who supplied us with the data said that she's never seen forecast as good as the forecast that we produce here at the University of Pretoria. That is, of course, not true. But because the fact that we've included her data has made her more susceptible to the forecast that we have created for her. And so this is one of the efforts, is trying to make the science more useful to a particular user, in this case, the farmer in northern Namibia.
Thank you. I'll give the panel a last chance. Anybody who wants to make another short comment? No?
Maybe I can. I mean, I'm not sure. I probably don't have like a very good example, but yeah, like I would say that in general, especially in European projects, like European Horizon projects, for example, nowadays there has been, I would say, quite, let's say, focus or like the stress or how basic support of these participatory approaches and like co-design and co-development of the different applications and tools. So like there is like this kind of, let's say, motivation or encouragement by the European Commission to really involve public and stakeholders and citizens to the projects. And also in the I think also in the Czech Republic, as I said before, and as we discussed, like I think nowadays, like in general, like the stakeholders and public are way more interested in these kind of co-design workshops and participatory activities, like then, for example, 10 years ago, or I think like especially like this 2015 heat wave, and after that, like the drought periods and heat wave, like kind of increased the, let's say, awareness of the public and also politicians about the climate and climate change and potential impacts. And before, like there was like very, let's say, I would say quite low interest by the society and the public. So but yeah, like lately we can really see like this increasing awareness of the society, and maybe it's also due to or thanks to like activities by, for example, the Czech Academy of Sciences that organize like really public events for, you know, like some festivals or fairs of science, and like where basically it's like once per year, like in Prague, like all the institutes or like present their basically research and work, and like the public can just for free come to visit this fair. So maybe that's also the way to somehow, yeah, again, like to raise the awareness of the public about the importance of the research, not only climate research, but in general the research. But yeah, I guess I don't have any particular example, I guess, but it's more just about this general, let's say, I think education of public and yeah, like yeah, and maybe just more promoting of the research also from the side of the institutions, that they just like more focus on the PR and like, yeah, presenting their work and results than, I don't know, 10 years ago, for example.
Thank you. Well, colleagues, we have got to the end of our time, and it is my job to just sum up. Well, there's far too much been said today for me to summarize everything, but I would like to just make a comment, and that is that I think it's very impressive, and it's quite surprising in a way that to people who are not directly in this field, how much data there is, how much work has been done, how much modeling, how effective modeling has become, and how very much we can now see the information being used to explain and to expose the societal impact of climate change, the way in which climate change is impacting on communities at a very personal level, and of course on human health and well-being. So I think what we've heard today is some obviously very impressive work, and thank you very much to the experts who have explained all of that to us. There is obviously a lot in common between what has been done here in South Africa and what is being done in Europe, and in particular in the Czech Republic. But the thing that obviously is very important is the collaboration, the coordination of the work that's being done. And just a few minutes ago, somebody made the point that the coordination needs to be within regions, within the countries, and also globally. So that, I guess, is perhaps one of the most important aspects of our discussions today is the importance of developing cooperative relationships and collaborations whereby we can communicate with each other as scientists, and of course with the general public and with our policymakers. So I think we have much to think about. I think the public would like to know a lot more, and I certainly think that there is enormous scope for publicizing, for discussing, for communicating all of this very important information that we now have. So I'm going to wrap up by saying thank you very much indeed to all of the colleagues who have given us presentations today. Thank you for the insights into just how much work you are doing and how sophisticated it is. And thank you also to the audience who have listened to this. I hope that you have plenty of useful take-home messages now. And finally, let me say thank you very much to the ASSAf colleagues who organized this meeting today. It has not been without its technical hitches, but I think we managed it. We are not running late, which I think is something of a miracle. But thank you for all of you for your attendance, and thank you to ASSAf and to the Czech Academy of Sciences for organizing this meeting. And I'm sure there will be more discussions as we go on. So thank you. Thank you very much, everybody, and enjoy the rest of your day. Thank you.
Thank you very much. Bye.
Thank you. Goodbye.